Sciencey, we do best. Missy helps you pass the test. Whee!
Hello and welcome to the How-To series of science videos with me, Miss C. In these videos, we will tackle the topics which at the moment make your brain hurt and make them less painful. In this video, we're going to focus on how to calculate the number of particles in a substance. And we're going to start off with a vocabulary breakdown. So, the particles can be ions, atoms, or molecules. What do we mean by the term mole? Well, if you have a look at video number 2, that's all about calculating moles. And no, it's not the furry nocturnal animal which ruins your lawn, but a unit to describe an amount of substance. 1 mole of any substance contains 6.023 times 10 to the 23 particles. This number has a special name. It's called Avogadro's constant. 1 mole of atoms or molecules of any substance will have a mass in grams equal to the relative particle mass. So that could be the AR or the MR for that substance. Now again, from video number 2, here's the formula to work out the number of moles. So the number of moles is equal to the mass in grams of the element or compound divided by its formula mass. And that could be for the element or a compound. So remember, for an element, the relative atomic mass, the AR, is equal to the relative formula mass, MR. And you can see we've got the little formula in the form of letters that you probably have seen before. N represents the number of moles, M is mass in grams, and MR represents your formula mass. So N is equal to the mass divided by the formula mass. Okay, so the calculation, do we do it? It's super easy. Look at this. I know, right? All you do is multiply the amount in moles by Avogadro's constant. Okay, so let's look at an example. This is super easy, guys. How many atoms are there in 5 moles of oxygen gas? Okay then, we follow the steps. Super simple. Multiply the amount in moles by Avogadro's constant. So in the question, we are told that we've got 5 moles, and the particles that we're looking at are molecules. We've got oxygen. Okay? So, there we go. 5 times Avogadro's number, and it gives you that number, 3.01 times 10 to the 24. Now, because there are 2 atoms of oxygen in each in each molecule of oxygen, we've got to multiply the answer that you just calculated by 2. And when we do that, we end up with 6.02 times 10 to the 24. So the big hint here is to make sure you read the question carefully to look at what type of particle. And if it's an element, you need to check to see if it's a monoatomic or multi-atomic element. And that just means if there's more than one atom in that element, or if there's just one atom in that element. Okay then, so let's have a look at another example. This one is slightly different, but it's nothing that you can't handle. So, how many magnesium atoms are there in 60 grams of magnesium? So we've been given the relative atomic mass for magnesium, which is 24, and this time we're talking about magnesium atoms. So with this one, we've got to convert the mass into moles. So that's what we do first. So we've got 60 grams. We divide that by the relative atomic mass for magnesium, which is 24, and that gives us the number of moles. And in this case, 2.5. Next step, we just multiply that 2.5 by the Avogadro's constant, and then we end up with our answer of 2.5 times 6.023 times 10 to the 23 gives us 1.505 times 10 to the 24. Super easy. Now here's a hint for you. You might get a follow-on question or indeed a separate question that asks you to convert, or you might need to convert the number of particles to the number of moles. And if you get that kind of question, all you do is divide by 6.023 times 10 to the 23 instead. So just look out for that on your paper. So, genius! How easy was that? I hope you found this video useful. If you have, please give it a thumbs up and hit subscribe so you'll be notified when more videos are added. If there are any other calculations in bio, chem or physics which make your head hurt, please add them to the comments box and you may see your request very soon.
All things sciencey, we do best. Missy helps you pass the test. Whee!